Welcome to this explainer. Today, we're diving into literally one of the most expensive problems in hardware tech, surviving the jump from a successful prototype to mass production. It's a journey that, unfortunately, claims countless brilliant startups. You see, most teams can build something that works perfectly once, right? Usually in a nice, controlled lab. But what happens when you need it to work thousands of times, reliably, out in the messy real world? Well, the structural collapse that often follows is exactly what we are going to explore today, using an incredible framework developed by hardware expert Chioma Aso and her team at Polymaticks Engineering.
Okay, let's start things off with a pretty brutal reality check. Chioma calls this the Unit 289 problem, and it is a fascinating and honestly terrifying phenomenon for any hardware team. Think about a standard production run. Unit 10 usually looks great. Unit 50, your confidence is building. But by the time you hit a critical volume, let's say Unit 289, things start to mysteriously fall apart.
The contrast between those two stages is just stark. In the early days, the pilot succeeds, the demo was beautiful, and hey, the funding arrives, everyone's celebrating. But over at Unit 289, the ghosts appear. All that optimism in the lab completely shatters when you scale, mostly because hidden manufacturing variations, tolerance stacks, timing drift, and supply chain inconsistencies suddenly rear their ugly heads. Here is our roadmap for today. We're covering 1. The Unit 289 problem, 2. The Valley of Death, 3. The 5 pillars of scale, 4. The audit and engagement process, and 5. Designing for scale today. Let's get right into it.
Section 1. The Unit 289 problem. The prototype to production chasm.
Welcome to the Valley of Death. Sounds dramatic, I know, but it's that notoriously painful phase between validation and the production ramp where risk doesn't just grow, it compounds exponentially. This is the exact chasm where teams that are absolutely phenomenal at prototyping suddenly hit a massive operational ceiling.
Moving to Section 2. The Valley of Death. Why beautiful demos fail to scale.
You know what's really interesting here? Most robotics and hardware companies don't actually fail because their technology is flawed. The tech usually works. They fail because they just lack the structure to scale it, period. And that is exactly why Polymatharix evaluates readiness across these 5 foundational pillars: architecture, sim-to-real, V&V and compliance, manufacturing and supply chain, and finally, the operating model.
Which brings us to Section 3, the 5 pillars of scale and their specific failure modes.
If you've ever wanted to see the terrifying autopsy of a failed scale-up, well, here it is. It's a total cascade of disaster. If even one of these pillars is weak, the whole system becomes incredibly fragile. Architecture failures lead to operational paralysis. Simulation gaps turn production into a live experiment. Testing turns into constant firefighting. Supply chains cause massive yield loss. And a broken operating model leaves teams feeling busy but totally ineffective. Let's unpack these, starting with architecture. So, for that first pillar, architecture is all about prioritizing system integrity before speed. When your architecture lacks modularity, you get tight coupling, and that means every minor change breaks something else. A hardware change ripples right into the firmware, completely destabilizing your mechanical foundation. Scale amplifies these structural misalignments, and boom, you've got total operational paralysis. You literally can't fix one thing without breaking 3 others.
Then we look at the sim-to-real pillar. Just take these 5 simple words. It worked in the lab. Those words have killed more deployments than actual technical failures ever have. Simulation is an incredibly powerful tool, for sure. But does it predict reality? Does it catch the weird edge cases and manufacturing tolerances? Because at scale, the lab is no longer the world. If the gap between your simulation and reality is too wide, your entire production run just becomes a live and very, very expensive experiment.
Moving to our third pillar, V&V and compliance. There is a massive mindset shift required here. Verification asks, did we build it right? But validation asks, did we build the right thing? Your testing absolutely has to be predictive, because if you're relying on reactive firefighting, bugs are going to pop up way too late, root causes will stay hidden, and scale will completely punish your timelines.
For the fourth pillar, manufacturing and supply chain, the question isn't theoretical at all. It's purely operational. Do you actually have the discipline to build 10,000 units? Having a successful prototype means absolutely nothing if your bill of materials explodes under volume. When you are building 10,000 units, a mere 2% yield loss spells financial ruin. Manufacturing does not forgive optimism. It demands rigorous discipline.
And finally, the fifth pillar, the operating model. You have to ask yourself, who owns decisions? How are risks escalated? Are your teams actually aligned? This pillar proves that brilliant engineering simply cannot compensate for misaligned execution. When this breaks down, organizations feel incredibly busy. Everyone is rushing around, but they're completely ineffective because decisions slow to a crawl.
Section 4. The audit and engagement. Crossing the chasm.
So, if your answers to those pillar questions earlier weren't super clear, don't panic. It doesn't mean your tech is bad, it just means your ramp-up structure needs help. Polymathrix mitigates these compounding risks through a highly structured, three-phase engagement. First, a tactical audit for gap analysis and to build a roadmap. Second, targeted implementation to actually fix those gaps. And third, oversight, actively supporting the system as it scales up.
This whole engagement is powered by the Polymathrix Audit Engine. This is a tool that augments human judgment to quantify your readiness, map out failure paths, and surface systemic risk really early. Basically, it's designed to catch those fatal tolerance stacks and team misalignments long before you ever hit Unit 289.
Section 5. Designing for scale today. The ultimate mindset shift.
Let's wrap up with this. Remember that scaling isn't just about building more units. It's a foundational design decision you are making today regarding every single interface, every supplier, and every KPI. If you design the structure to support your units early, you can completely avoid the valley of death. So, the final provocative thought I want to leave you with as you look at your own prototypes is this. As you build today, are you truly designing for scale? Or are the ghosts of Unit 289 already waiting for you?